Alright, so we're going to be working on the week 2 example 1. To start out, we're going to first set up our stock geometry. So we'll go in here to WinMax and we'll go to the part setup and we'll go to the More tab and stock geometry. So we have this option for manual stock sizing. This will allow us to create whatever geometry we want. So when we render it out, it will display accurately to what our part actually looks like. So we'll go ahead and hit yes here, and now we can define our stock. We can either define as a square or a cylinder. For now, we're just going to do a square. So we'll come out here, and we have 2.5 in Y and 3.5 in X, and 1 inch thick. So we'll define that here. And then we also have an option for a reference point. On our drawing here, they call out the bottom left-hand corner. Most prints will always be the bottom left-hand corner. It really depends on what the engineer wants to do, but typically it's the bottom left-hand corner. So we'll just leave this reference at 0, 0, because that's going to be the bottom left-hand corner. So now we'll go ahead and create our tools, and we'll go to the tool setup. On this sheet here, it calls out a 5/8 center cutting end mill, so we'll just program that in here. We're going to call our end mill tool number 60, and our tool type, we want to define it as an end mill. So now we specify our diameter as 5/8, so we can type in 5 divided by 8, and it will automatically calculate that for us. Now we can define predetermined speeds and feeds that will populate the programming as we go along. So here we can kind of put whatever we want for now. When you actually get to programming, you'll tweak these as you run the part. You'll start at a predetermined value, and as you run the part and listen to it, you can tweak it as you need. So here we'll just start out at 6,000. Always remember, if you are going to use coolant, to turn it on. It's a really easy thing to forget, and you go to run your part, and if it's not turned on and you don't notice it, it will eat your part up pretty quick. So always keep that in mind. Now for a feed, we'll just assume this is aluminum for now. Pretty much all the parts we're going to be programming, we'll just assume aluminum, just to simplify things. Alright, so now that we have that started, we have all of our tools set up, we can go into our part programming. So we go to this part programming tab here, and we're just milling out this little circle here. So what we want to do is milling. We have all these options. We want to do a mill circle. We could do this with lines and arcs as well, but a mill circle is the easiest way to do this. So now here we can define our center point. It's at the midpoint of the block. Then we define our radius, so it'd be a 1 inch radius. Now our Z start, you always want to start above the part. The Z start point is basically the machine will rapid as fast as it can to this start plane. So you want to make sure you leave some extra room above the part. If you put this at 0 and you're machining something, it will rapid to the top of your part, and if you do that on a difficult material like stainless, it'll pretty much instantaneously ruin the bottom of your cutter. So always leave a little bit of a gap, and also when you go to run your part, you can watch for that 50 thou as you approach. You can turn on your distance to go and watch it as it comes in. And that will give you a little bit of a cushion room to keep from crashing into your part. So now we want to specify our Z bottom, which is going to be the final depth of our cut. And it calls out a 0.5 depth on that pocket. The start angle, we can just ignore that for now. Sometimes that comes into play, but for right now, it's not that important. So now we define our tool as tool 60, and you can see when we type that tool in, it auto-populates these values. So now that we've auto-populated these values, this is what it's going to machine at. We can always tweak these if we want to. If I want to change this to 10 or 20, I can change it however I want. But for now, we'll just leave it at the predetermined values. Alright, so right now our milling type is on. What that means is there is no cutter comp. So what we want to do is we want to change this. So we're milling inside of this circle. So if we do an inside, it'll just bound to this edge here, and that's all it's going to do. It's going to blend in, spin around, and blend out. If we do that, we're going to be left with a slug in the middle here, because our end mill is not big enough to cover the 2-inch span. If we had a 1-inch or bigger end mill, we could do that and just spiral in, and it'll remove all the center material. But since our end mill is smaller, what we need to do is a pocket boundary. And what that will do is it will plunge in the center of our predetermined geometry, and then it will spiral out, and that will remove all of the material. Now we have this option for pocketing type, and we can choose outward or inward. Outward means it's going to plunge in the center and spiral out. Inwards means it's going to plunge on the outside wall and then spiral in. Anytime you're doing a pocket, for the most part, you're going to do an outward, just because it'll remove the material more consistently. If you spiral inward, you'll be left with a post in the middle, and as it approaches that post, oftentimes it'll rip it out and leave a divot in your part. So you almost always want to do outward. Now we have this pocket percentage overlap. Basically, that just overlaps the tool over itself so that it has constant material removal. If we put this at a really small value, it'll have almost no overlap whatsoever. The bigger your overlap, the smaller your step over. So if we had a 99%, it would have thousands of little step overs. If we had it at 1%, it'd be 1 or 2 step over, and that's it. So always keep in mind your tool geometry as you're changing this, because if you have a large corner radius on your end mill, it'll leave a step in the bottom of your part. So you need to make sure your overlap blends those steps together. So for right now, we'll just leave it at 50. That shouldn't be a problem. Now your peck depth, it all depends on your material and how you're approaching it. For now, we'll just call it 0.15. You never want to go, for the most part, you don't want to go deeper than half of your cutter diameter. That's just a standard rule. It doesn't always apply, but typically you don't want to do that or put too much torque on your tool to break it. Plunge feed, you want to plunge. If you're plunging into a material with an end mill, you typically want to do it very, very slowly. So always keep that in mind. Alright, so we filled out all the values, and we've got our tool set up and our stock geometry set up. So now we should be completely done with our program, so we'll go ahead and draw it and see what we get. So we can see it peck and then spiral out. Now we can change our view to isometric. We can see what all it did. We can rotate it around. If we want to see our XZ plane, we can see the depth here. So everything looks good, and we should be done with that. So now we'll go ahead and save out. We'll go to our program manager, and we'll go to save as, and we'll save it as week 2 example 1. I'll put my initials. Alright, and that should be it for this example.